All right, it is my pleasure to introduce a good friend of mine, Brett McLaurin. He is with Bloomsburg University, but we go all the way back to Wyoming. So we both did our grad work in the University of Wyoming, in lovely Laramie, Wyoming. And we have more stories about those couple years than we have time to fill tonight. So that's going to have to wait for another session. So I'm not big on huge introductions, so that's enough. He's a friend of mine, so he should be a friend of yours. So there we go. It is all yours. And let me change the camera. There you go.
Where's the pointer? Oh, right there. Okay.
There you go.
Very good. All right, thank you very much for the opportunity to come out and talk about some of this interesting interval up in the Appalachian Plateau. One of the things about it, after I'd submitted this title, I'm like, well, you know, this section's kind of interesting in that, well, we really don't know where the Devonian-Mississippian boundary is, so it could be Mississippian. And then this idea of a Silcrete for interpretation, I'm like, well, I'm still not 100% on that, but I at least wanted to talk about and maybe open up some ideas about some of these observations that have been made in this interval. First, I'd like to thank the Pennsylvania Geological Survey. It was a group that first introduced me to these rocks up in the plateau. I remember the first trip up there, Bill Kachanov, Bill Bergonia, Vic Schema, Rosanna Bear, George Love, and we were looking at Catskill. We were looking at Huntley Mountain Formation, which we'll be talking about tonight. So that was a lot of fun and got to know a lot about the stratigraphy up there. This work, some of this was from state map support for mapping the LaPorte Quadrangle up in Sullivan County. And then Gail Blackmer for these opportunities. Cliff Dodge, we've been in the field looking at haystacks and other stratigraphy throughout LaPorte. Steve Shank, what was really neat about some of these state map projects were the samples that were collected, and we had basically chemistries run on them. And so I'll be using some of that data as comparison to the haystacks. And interestingly, a lot of the research on the haystack has been done by Bloomsburg University faculty over the years. Joe Hill's probably been one of the major ones, and I'll talk about some of his interpretations there. Chris Wisner's another faculty at Bloomsburg University, and then some of the students that have helped me out in the field from time to time. So those of you may not be familiar with it, what are we talking about here? What is this haystacks interval? We're up here in Sullivan County. There's LaPorte, we're just north of there. Here is the edge of the Allegheny Front. So we're just north here of, northeast of Williamsport. And this is a locality that's along Loyalsock Creek. This image is from the State Forest Service map. And so there's 220. And this is named for Haystack Rapids here along Loyalsock Creek. If you would ever like to go there, if you haven't been there, there's a nice parking area. You can hike down the hill. If it's a little rough climb, it's a little challenging for you, you can be dropped off here along the road. And it's a fairly flat grade most of the way. I think it's a few miles. I can't remember. I hiked it back in March. On one of the very nice days up in Sullivan County. Sometimes in Bloomsburg, it's sunny and 70 degrees, and I go up to Sullivan County and it's 50 degrees and raining. So it can be quite a contrast. So first we're going to start right here at Haystack Rapids. And these are a couple of other locations where it's been observed along the Loyalsock Creek there. So this is a pretty typical photograph. Many of you have probably seen photographs of the haystacks before. It gets its name, as I understand it, from the rounded shape that's caused by Loyalsock Creek. And it's within this Huntley Mountain Formation, as I said, you know, it's Devonian to Mississippian, where exactly that boundary's at. I don't think it's been firmly established. And one of the things I wanted to do was try to understand the history of this, like when was this first described? So I went online and I started searching through newspaper archives. And I really couldn't pin down when it was first named Haystack Rapids. The earliest reference I could find was like 1892. And they were talking about a tornado coming through the area, and it had crossed Loyalsock Creek below the Haystacks. And then another reference was from 1926, and they had proposed putting a hydroelectric dam here, which I thought was kind of interesting for this area. Going through these newspapers at that time, you see very interesting things going on up in this part of Sullivan County. So why is it so special? Why are we talking about this one interval? Well, it's distinctive and recognizable. Everything you want in stratigraphy, right? We're here within a package of fluvial rocks, and having worked on fluvial systems in the Cretaceous of Utah, if you have a marker horizon, thank you, because you usually don't have good ways to correlate in these intervals. We don't have, in Cretaceous, we didn't have much in the way of fossils, so it was really hard to do some of these correlations regionally. So right here we can see this is the Haystacks right along Loyalsock Creek, and right below it here we can see cross bedding within the Huntley Mountain Formation. And so when you see the Haystacks, even if you're driving down the road at 55, 60 miles an hour and you drive by a block of it, you're like, that's Haystacks. It's that recognizable. Once your eye is tuned to it, you can see it. You'll easily recognize it in the field. So this is right at Haystack Rapids. This is, again, another typical profile. This is at Dutchman Falls off to the east on the Loyalsock Trail. And again, it's about 1.5 meters or so at this location. Again, notice the massive nature to it. And also, we call it the Haystacks. That's kind of an informal designation, a really informal designation. So this has not been defined as a bed or a member of the Huntley Mountain Formation. So what would you call it? Haystack Rapids member, Haystack Rapids bed. That hasn't been established yet. So when I say Haystacks, again, this is obviously an informal designation for this particular interval. And why is it distinctive? Why is it so different than the Huntley Mountain Formation? Well, over here on the right, we have a photomicrograph of typical Huntley Mountain. Clays are present in it. We have muscovites. We've got grain-on-grain contacts here. We've got chert, polycrystalline quartz, which is probably more metamorphic sources there. And then over here on the left, we have the Haystacks. And one thing I see time and time again in these thin sections, it's kind of this floating kind of fabric to it, in that in between the grains, and not all of them, but you have this microcrystalline quartz matrix here. And I was curious about, could there be some amorphous phases in here? Could we be seeing some opal or something like that? So I put it on the XRD, and it's all quartz. I didn't. If there's amorphous phases, there's not much, but it's you could basically use it as a quartz standard for X-ray diffraction. It's that clean of a formation. But notice you don't have any of the clays here. Occasionally you'll see some muscovites. It seems other minerals in here are zircons. They seem to, whatever process is developing the Haystacks, it's preserving the zircons, but the clays are being completely obliterated. So we'll look at some more of these as we continue on. So let's talk about some of these proposed origins. And there's a number of them. Some have just been speculation, and there have been 2 field conferences. One was in 2006 with Joe Hill, who I'll be talking about some of his work, and then I presented some of my hypothesis about it at the 2019 field conference. So if we go back through some of these, one of the first was Gilmeister and Springer. And again, these were both Bloomsburg University professors. And it was postulated that it was a paleoseismite based on some of the sedimentary structures that they thought they observed in that, some dewatering features, I think it was, as I recall, in their work there. Possible tsunami deposit. This was one of their hypotheses about that formation. Woodrow 2006 also, and Hill in 2007 has suggested that. Debris flow, and so you're seeing a theme here. Event, some sort of event bed. And then one of the more interesting ones is possible bolide impact. Joe Hill has has found shot quartz within this interval. He has really good evidence for it. And then finally, well, here's the Silcrete. So out of all of these, the least exciting one is the one I'm going to be talking about tonight. And again, I'm not 100% dedicated to the Silcrete hypothesis. I think we'll just talk about it. How about that? But first, we got to get some of this regional geology established. What's going on in this area? We're focused here on the Huntley Mountain Formation, again, Devonian to Mississippian. And before I get into the details about the Huntley, let's look at where we're at. So we're just north of the Allegheny Front here. We're in Sullivan County. I've outlined the LaPorte quadrangle here. When we look at the stratigraphy in this part of the plateau, about the oldest you'll see is Lock Haven Formation there, and there's a little patch of it there along the Wilmot Anticline. But overall, most of LaPorte, with the exception of a little bit of Catskill down here in the south, is this section of Huntley Mountain up through the Pottsville and the Allegheny. And the Haystacks, most of the area we'll be talking about is going to be just south here of the axis of the Burness syncline. And that first map I showed you of the Haystacks along Loyalsock Creek, that's this area right here, just north of LaPorte. Again, the Huntley Mountain Formation is this area in the reddish color here, and we can also see it obviously on the north limb of the fold. Interestingly, we do have some coals here up in the Pennsylvanian part of it. There were two coals, I think, talking to Cliff Dodge, A and B were some of those coals that had been mined in the past. And so the Huntley Mountain Formation, this is a number of paleoccurrents I pulled. Some of these are from Ricketts Glen. They're not all from the LaPorte area, but strongly northwest directed currents. And just to go over some of the details about the Huntley Mountain Formation, just to provide some additional context, it's about 180 meters thick. This is from a core that was drilled just to the south of where the Haystacks is located on Loyalsock Creek. It's a series of amalgamated sandstones, and this is a term we use in the western interior. These are fluvial channel bodies that are not really isolated from one another by extensive floodplains. That is, they grade into each other laterally and vertically. We called it multilateral and multi-story. These terms describing the alluvial architecture of this particular interval. Lots and lots of cross bedding. It's very characteristic in the Huntley Mountain Formation. And I interpret it more of a low to moderate sinuosity fluvial system. And the Haystacks is in about the upper 40 meters of the Huntley Mountain Formation. This is a great road cut. This is just south of LaPorte. This is on US 220. As you can see, it's a great place to take students. And the contact with the underlying Catskill Formation is off to the left side of the photograph here. I think it's a few hundred meters down the road, but lots of sandstone. I think that's pretty obvious from this photograph here. And you can see some through-going surfaces. So a quick interpretation, these thicker lines would represent erosional surfaces, and these yellow lines here would represent some of the cross bedding that's internal within some of these channels. And if we take a closer look, we can see this characteristic flaggy appearance, which I think is pretty characteristic of the Huntley Mountain sandstones. I often tell students, when you're doing geologic mapping, you may not always have good outcrop, but you're in the Huntley Mountain, you look for the stone walls, and they're made of these perfect little flat, flaggy pieces of Huntley Mountain. It breaks off very neatly, and so you always know where you're at because the nature of how this breaks apart and weathers. So this is pretty characteristic of Huntley Mountain. So, when we go back and look at pictures of the Haystacks again, you'll note the contrast in the field appearance of this particular interval. So we'll go back to Loyalsock Creek here and look at some additional features. So we're going to start back over here on the Haystack Rapids interval. And here's a nice view of it. We're looking upstream, up towards upstream into Loyalsock Creek. Again, notice here how massive this interval is. Just below it, this is the contact with the Huntley Mountain Formation. Again, we can see the sedimentary structures. You can note the cross bedding there. This wasn't so bad the day I took this photograph. There have been other days when the water's really low, and a lot more of this section is accessible. We saw this interval earlier, but just to come back to it again, we see the massive nature of this, very distinctive from the underlying and overlying Huntley Mountain Formation, typical sandstones. And then, of course, we had to do a drone flight, just to see what this looks like from above. Again, these rounded masses, one of the things I'd started thinking about was this a reflection of the distribution of the haystacks, or is this just simply Loyalsock Creek doing its work and weathering and eroding this? What's also neat about this is we can also see here and here and here, we get a little glimpse of the underlying sandstone. So this was a nice opportunity to see what this thing looked like from above. And if we, using the digital surface model generated with drone flight, this is the approximate base of the haystacks. And so again, it's a good guide for the thickness. We're looking 1.5 to 2 meters or so when you're looking at this interval, at least along Loyalsock Creek. In most places, I've observed it, it's something around 1 meter to 1.5 meters. So next, we're going to come over here to Dutchman Falls over here by 220. This was the site where we went to in the 2019 field conference, and I think the 2006 field conference also visited this location. It's a pretty site. It's a nice hike. We have the waterfall here. We can see the kind of the massive nature of the haystacks here. Interestingly, when we go back to Haystack Rapids, the haystacks are right there at the level of Loyalsock Creek. Well, here it's about 10 meters up above the creek. So this starts, introducing questions about, one of the things I've thought about is, are we seeing multiple intervals of this haystacks, or is it one interval? Why the difference in elevation between here and the creek? Is that the plunge related to the Burness syncline? Are we seeing that? What exactly is going on there? Approximate base of it defined there. There's the top. And of course, going back and looking at some of the details, we can just see, again, pretty massive. I think I've established that point so far. Observations. Again, these are not all mine. This is some of the work Joe Hill and others have done over the years, but looking at it, it makes perfect sense to me. We're in the upper part of the Huntley Mountain, upper 40 meters or so. Good. It's easily recognized. Going back to what I said earlier, we possibly have this horizon, this interval, which may be useful for correlations in this particular area. Why is it easily recognized? That's silicification, which has removed the clays within the Huntley Mountain. Lack of sedimentary structures. I know there's been some evidence of dewatering structures, things that look like roots, but otherwise the cross bedding, that's been completely obliterated. And our range of thicknesses 1.5 to 2 meters and up to about 300 meters extent. That, and then the largest area I've seen the haystacks is right at Haystack Rapids, and then upstream there's a small zone. But it's interesting that it seems to be patchy. In between, you don't see it. You'll see sandstones of the Huntley Mountain Formation, but you won't see the haystacks, which is, I'm wondering about its exact distribution related to that. Is it patchy? Is it covered up by other sediments? What exactly is going on? So where is it? Let's look at the broader distribution of it. These little boxes here are where I've identified it. This is focused right here along the Loyalsock Creek area, northwestern part of the quadrangle. And then during pandemic, I was hiking with my wife at Ricketts Glen State Park on this, was it Old Beaver Dam Trail. And, I normally don't like to hike unless I'm doing some geology. And we turn a corner and I'm like, that's Haystacks. Remember I said it's distinctive, it's recognizable, and yeah, it was Haystacks. I'll show you some pictures of that in a minute. So this distribution, again, is roughly, that's about 30 kilometers from northwest to southeast. And interestingly, Joe Hill in 2008, he had some students going out and mapping the distribution of this, and he determined that, yeah, about 30 kilometers was the northwest to southeast extent of it. But then he noted that from the northeast to southwest, it was about 55 kilometers. So we're seeing this distributed over a very broad area. And I have not looked at it in these other places. I reached out to Joe to try to, if he would share some of his location data. He's chair of the department at Sam Houston State University in Texas. So I don't hear from him very much anymore because of his chair duties. So we're seeing this interval. It's not just isolated right there in Loyalsock Creek. This interval can be recognized at multiple locations throughout Sullivan County and into Columbia County. This is down on the state game lands, this location here, it's about maybe 5-6 kilometers southwest or southeast of where the Haystacks is. And this story is interesting to me because this is the first place I saw the Haystacks. I had heard of it. I didn't know anything about it. I'd heard stories, oh, it's this weird layer in the Huntley Mountain Formation. And so obviously it was winter time. I was out there hiking around and I come across this interval. My wife's with me and I'm like, looks weird. What could this possibly be? So I took my hammer and cracked it. It looks like a quartzite. What I was seeing, that was the silicification. And so at that point, I'm like, this is the Haystacks. And I have it in my field notebook. This looks like Haystacks. What I was told was probably Haystacks. So this is the first location I saw it. I had not been to Loyalsock Creek at this point. That's how distinctive it was. And then this is it at Ricketts Glen. Quite extensive in this location. From what I understand, it does occur, I think Joe told me it occurs along the Falls Trail, but it's thinner. This is just to the north and west of the Falls Trail where I identified this interval. And no, I did not take a sample. I was in the park. So let's get to the fun stuff. Let's see what's going on under the microscope with this. So first here's the Huntley Mountain Formation. Now I like playing around with this kind of stuff with these photomicrographs. This is 6 separate photomicrographs all merged together so we can get a broad view of what's going on here. We see quartz. That's pretty obvious. We have these zones where we see the clays are concentrated. We've got some chert fragments here, a few possibly polycrystalline quartz, grain-on-grain contacts, probably some pressure solution going on that we can observe here. And if we compare it to the Haystacks, now this sample I took just below the Haystacks at Dutchman Falls. So this is not from some rando sample somewhere else. This is in context right beneath the Haystacks. And if we, again, we contrast it here, I'm seeing more of a floating kind of fabric where we have the microcrystalline quartz in between the grains. We see chert, we see polycrystalline quartz there. And so again, looking at this, we can see these distinctions between the Huntley Mountain and the Haystacks, not only on the outcrop, but also at the microscopic level. Now, here's where I think a lot of my ideas may diverge from others. I don't think it's any different provenance-wise. One of the ideas about this was this is some distinct provenance. I don't think it is. I did point counts on a total of 8 samples. And when I plotted them up on the old QFL diagram, if you don't remember this from school, again, the QFL, the Q, that includes chert there. And we include polycrystalline quartz metamorphic rock fragments here in the lithic. And so we see overlap between these samples. We take it further on the QM FLT, we take out our chert and our polycrystalline quartz, and it plots a little more, put that in the total lithics, and it plots a little farther down. And again, these values are pretty consistent with the type section of the Huntley Mountain Formation. But my point here is I don't see any difference between these from a provenance perspective. The difference to me between the Haystacks and the typical Huntley Mountain, it's the matrix. Huntley Mountain has that clay, the Haystacks does not. So on a whim, I grabbed a couple of samples and I said, you know what, I'll send these off and see what our chemistry looks like. So I just have 2 samples of Haystacks I analyzed, both from there at Dutchman Falls. And from these other state map projects, I had 7 samples from the Huntley Mountain Formation. The first thing you notice about the Haystacks is average 98.3% silica. We look at these other values and they are significantly lower with the exception of titanium. And what I'm seeing here, you know, with the aluminum and potassium, I think that's what we're seeing in the clays and the muscovite that's preserved in the Huntley Mountain Formation, but it's not here. Some of these trace elements, I don't have a diagram for that, but 10 parts per million uranium in the Haystacks. We're not seeing that much at all in the Huntley Mountain Formation. But overall, when we look at all these other trace elements, the Haystacks is depleted in everything. It's just silica rich. So if we compare the Haystacks, and this is my analysis up here, I'm plotting silicon versus aluminum. And from these other state map projects, this is all of these chemistries. So we're starting here in the Lock Haven, and vertically, we can see, I call it a cleaning upward as we're going from the Devonian up through the Mississippian within the Burgoon. So we see increases in quartz, decreases in aluminum. And so again, these blue dots here would be the samples of Huntley Mountain Formation. Now the Haystacks, yeah, it's pretty close to the Burgoon in some cases. If you see the Burgoon, especially the upper parts of the Burgoon sandstone, it's a really clean aeronite. But it's just very interesting that this Haystacks, there's such a high amount of silica present in it. Oh, let's look at it in 3D. How about that? So this is the same axes I had before. Here's potassium increasing to the right. And again, this is just pretty much showing you the same trend as before, that we're seeing all these formations clean up vertically, increasing silica, but the Haystacks is this outlier. So let's talk about the Silcrete hypothesis. One thing is, well, what exactly is a Silcrete? This is the definition from Ulliott and Nash in their summary paper talking about all things Silcrete: highly indurated duricrust as a result of near-surface accumulation of secondary silica within soil, sediment, rock, or weathered material. When you start digging into the literature related to Silcretes, you find out that most of it is not from North America. You're looking at Europe, Africa, Australia. That's where most of the research has been done. And interestingly, when I'm looking at some of these different models and evaluating them, you notice a lot of these are in rocks that are pretty simple. They're young. They haven't been deformed. You know, very different from what we're seeing here in the Appalachian Plateau with these folded rocks. So they can do correlations. They can trace these things great distances. I think they have overall a simpler geological context when they're working on these Silcretes. And what made me start thinking about Silcretes was this first trip I mentioned with Bill Bergonia and all those crew of the Pennsylvania survey. And we're up in Bloomsburg. We're looking up in the Pennsylvanian. I can't remember if we were in exactly the Pottsville or the Allegheny. And we find this interval, and it's a Silcrete. And so that's what started getting me to think, well, maybe this is a thing. Maybe this is occurring in more than one place. So that's what initially got me interested in this. And then using data from Nash and Ulliott, I plotted the Haystacks here with some of these other Silcrete analyses that have been done, and it's in the ballpark. Again, we're starting our silica down here at 91%. And looking overall at our aluminum, and we can observe here that it's much lower than what we would see in most other parts of the Huntley Mountain and some of these other formations. So very similar. Well, silcretes can form a number of different ways. And so to summarize some of these, if we look at Nash and Uliet, there's the pedogenic ones. These are soil profiles, and there are phases of dissolution and recrystallization. You can see features related to soil development in these particular types. And then there's the non-pedogenic variety, and these are ones that are more going to be related to silicification at or close to the water table, drainage line silcretes. These are actually more kind of groundwater discharge features that you will see develop along fluvial channels. And actually, distribution of these silcretes and some examples, particularly in Australia, helps you define the actual channel pattern. The channel's gone, but the silcretes are left behind. And you can use that to actually map out the channel itself, the paleo channel. And then there's the pan-lacustrine ones. These are more related to ephemeral lake basins, mainly more highly evaporitic kinds of conditions, you know, and so that starts getting me thinking about, okay, what's our climate like at this time? What's going on? You know, this is part of the issues. We don't have this time control. It'd be very helpful. You know, if you go through the literature, especially the earlier literature on silcretes, you'll see this, it's arid. It's a climatic indicator, but some of the later literature on it says, well, it can be arid, but it also could be generated by human systems. So it's not a slam dunk, so to speak, for some sort of climatic signature, as much as we might want it to be. So when we look at the pedogenic silcretes, complex profile. Again, if it's a pedogenic silcrete, well, that tells us something. If you have a soil developing, you're dealing with a stable floodplain for a long period of time to get that development. And that has some significance from a stratigraphic perspective. There's this vertical jointing, almost this columnar type jointing that's observed in pedogenic silcretes, what they call a complex microfabric. You'll see all these features, coliform features. And then the silica cements can be quite variable. It will go from opaline down at the bottom to more microcrystalline quartz toward the top. And the induration will be different from the bottom to the top, less indurated all the way to more indurated vertically. If we look at the non-pedogenic varieties, again, a fairly simple profile. That's fine and dandy that, from the literature, they're related to landscape depressions, drainage lines, water tables. We don't have that luxury to be able to see that kind of detail, unfortunately, in Sullivan County. But they don't have any of that columnar jointing and a fairly simple microfabric. So sometimes I want to lean toward the pedogenic interpretation, but for right now, I think it's more related to possibly groundwater development. And again, whether it's a drainage line or some sort of other water table feature, I'm not 100% sure of yet. Part of the issue is this is a drainage line silcrete from Australia. And again, these dark areas here are the actual distribution of the silcretes that's helping define the location of this channel. And in this particular instance, these silcretes are capping the edges of the channel itself and helping define it. Now, again, drainage line silcretes are related to groundwater discharge, again, more evaporitic kinds of conditions. This is the Fontainebleau sand in France, and this is where this groundwater silcrete model had been developed. And what's happening here is this landscape is being dissected. We're having groundwater silcretes develop at multiple levels. So you're not just having one silcrete, you're seeing zones where each of these are developing when you have stability in the water table as this is being dissected over time. We got to show an analog, right? And this was, to me, this is one of the cool things about geology. The next few slides I'm going to show you are not Pennsylvania. They're Utah. And why am I talking about Utah? Well, I had been looking at the Haystacks, And I had a student who wanted to do a research project, and she wanted to do a project with drones. And I said, okay, well, let's not do it in Pennsylvania because, you know, trees. Let's go somewhere where we can see really good geology without a bunch of vegetation to deal with. So we decided to go out here to Utah. We're just south of Green River. And the thing that caught my eye here, and I wasn't obviously first to find this, we see these little snaky looking things right here. These are early Cretaceous paleo channels, and you're seeing the actual channel form from above as it was in the Cretaceous. What's happened is the shales have eroded from around it. And so we have these beautiful overhead views of these fluvial systems. Now, of course, in outcrop, you're looking at a vertical profile. We don't get to see that, but here in Utah, we did. And there's a number of these scattered all over the place. When we published on this at GSA, I think it was 2017, 2019, you know, I had people coming up to me like, oh yeah, we flew that too. So there's been a lot of geologists with their drones out here examining this section because it's really great to be able to see a lot of detail of these fluvial systems and be able to reconstruct their architecture. So these are what these look like. It's inverted topography. So the shales have eroded from around them, and so you're left with these long sinuous ridges, and you climb up on top of them. And we were taking, you know, paleoccurrent indicators, sedimentary structures, defining some of the geology of the fluvial system. Well, one of our last days there, we run across this. I was like, oh, that kind of looks a little familiar. And in this particular case, what I'm talking about is this darker color, this grayish black cap. Now here, we can still see the cross bedding, and it's continuing on down. And I'm like, okay, this is interesting. So I cracked it with a hammer. Quartzite. Oh, where have I said that before? The Haystacks. And I showed it to my student. I didn't say quartzite. And I said, what do you think this is? She's like, I'm afraid to say. I said, just say it. She's like, it looks like a quartzite. I know we're not in metamorphic rocks. I said, this is like the Haystacks. I think this is a Silcrete. You can see the book cliffs off in the background. You remember that? Yeah. So I saw this. I'm like, oh, and it's got this kind of grayish patina, black patina to it. We may be able to see that in the drone imagery. But before that, I did take a sample, and here we go. So we have a silica cemented sandstone. In this case, this is chalcedony. This is not the microcrystalline quartz, but it's a silcrete. We have some detrital chert here, mostly monocrystalline quartz. But I'm like, oh, I wonder if this is, you know, could this be an analog? So here's a couple of drone photographs. It was a hot day, so I didn't get my overlap between these two flights like I wanted to, unfortunately. And so this, you're actually seeing the part of a meander here that's preserved. This is dropping off the edge of a cliff on this side. And you'll notice these darker areas that wrap around along with the meander. And when we went and mapped these out, these are all silcretes. So these silcretes here are helping define the actual channel. And well, the neat thing about it was it just wasn't in this one channel. We observed these on pretty much every one of these channels we imaged with the drone, and these are all at different stratigraphic levels. So that's what got me thinking, okay, is it possible that the Haystacks isn't this single unit, that it could be a zone where conditions are right, where we can see silicification at multiple intervals, and you know, who knows how thick this zone could be. And I'm in no way saying that the Cretaceous of Utah is the same system as the Devonian of Pennsylvania. I'm just saying this got me thinking about, okay, you know, and trust me, having worked in fluvial rocks, I would love a time stratigraphic interval that could be traced around. I just wanted to, just that thought exercise of maybe it could be multiple intervals here. To summarize some of this, it's a horizon silica cemented sandstone, 1.5 to 2 meters thick. And what's interesting about going through the silcrete literature is most of the silcretes they describe 1 meter 1.5 to 2 meters in some cases. So I think that's pretty interesting. Obviously, it's distinctive, it's massive, it's resistant. I always like to say, if the haystacks is there, you'll see it. If you try to, there's been some areas like at Dutchman Falls there along the Loyalsock Trail, I try to walk it out and it's gone. Well, is it covered up by colluvium, or is that just the extent of it? And as I mentioned, when you see it, you know it. It's very resistant. Trust me, crushing up this sample to do the XRD it took a while to do that. There are places, and Cliff Dodge has been there with me, in the northwestern part of the quadrangle, where there's this road going over the haystacks, and you can see where they tried to rip it with the excavator. And there's these scratches in it. They gave up pretty quickly because it's extremely indurated interval. And I'm going out and just saying, when you compare these, I don't see a difference in the provenance. So if this is some special material that's been brought in from some event, you know, maybe I'm wrong, but I just think that from looking at enough thin sections of this, I think the provenance is similar. The difference is the matrix material. The clays have been blasted away, replaced, altered in some way to the silica that we see in the haystacks. And of course, when we look at the chemistries, higher silicon, but we look at these other elements and much lower compared to these other formations, particularly the Huntley Mountain Formation. So what about the origin? For now, I think it's probably a silcrete formed from groundwater processes. You know, I'm still open to other interpretations from this. I guess this is one of those things when you're a student and you're thinking about stratigraphy and you're kind of drawn to these bigger pictures, these, you know, these exciting types of interpretations. And I think the silcrete is me kind of, as I've aged, starting to think about, well, you know, maybe it's just something simple like a silcrete. And I know that's not as exciting as I said, but it's just an interesting process. And here's the other thing. So if I'm saying it's a silcrete, well, you know, it's not an event, it's a process, it's diagenesis. So when we look at some of these other interpretations, that's the key difference. So is it that last point when I was using the analog in Utah for those silcretes, is it a single layer or is it a zone? And we may see multiple, and you know, how thick could it be? I don't know. You know, as Cliff says, well, if it's a zone, well, you need to be able to show that. And I agree. So there's that part that needs to be established. So the remaining questions, well, is it an event or a process? And this is one I've toyed with. Well, if it is a silcrete, why just there? Are we missing? Are these other silcretes? I talked about, we have found silcretes in the Pennsylvanian. Why here? I've seen the Huntley Mountain quite a bit, and there's only one thing I've seen that looks like the haystacks, and that's the haystacks. Mansfield, Bloomsburg areas, Trout Run, you don't see anything that looks like the haystacks. So what's going on? If it is a silcrete, what's going on to just give it to us in that interval? And you got to explain the shot quartz. That's a really, you know, that's a pretty good observation, obviously. And talking to Joe Hill about this, you know, one thing I brought up was where, well, why did you look for shot quartz? And it's, well, here's this distinct interval, it'll look weird. And my point is, if we went through the entire stratigraphy, all these sandstones in the Paleozoic of Pennsylvania, how many places might we find shot quartz? Remember, one of the things about impact structures on Earth is they get eroded away very quickly. I think it's perfectly reasonable that there was some impact sometime in the Devonian or Mississippian, and it was eroding, and you have shot quartz, just like detrital zircons, right? Detrital zircons are evidence of these mountain ranges that are eroded down to nothing. Why couldn't we have the same thing with shot quartz? Again, I think it's a great idea. I just think it needs we may need a little more work with that. You know, and it could be a combination of things. One of the questions I've had is, what does an impact crater do to a groundwater system? Can it result in silicification? Some of the background work I did, I couldn't find any relationships there, but is that possible that there could be some association with the two, or one of these other events possibly, the tsunami or the paleoseismic? But yeah, the shock quartz. And when I talked to Joe about it, one of the things I'd initially said was, well, he didn't look at the other intervals. He did look at the other intervals, and he did not see shock quartz in those. So we still have to explain that. So that's all I have, and I appreciate your time, and I look forward to any questions and discussions that we can have about this. Thank you.
Okay, we're going to open it up to questions, and for those of you online, post your questions in the chat. We have one already. Do you have any idea about the possible groundwater or geochemical process that would result in a floating matrix as observed in the Huntley Mountain Formation versus grain on grain observed in the Haystacks?
I forgot to mention that. If it's a silcrete from groundwater processes, that's going to be soon after deposition. And so my idea is it's pre-compaction, that you have the silicification and then you have the compaction of the other intervals, and that's why you see the grain on grain contact.
Open it up. Anyone? Questions?
Time-wise, you're not talking about much.
Right. As few as, from some of the evidence, 30,000 years, if even that, 3,000, 30,000 years, not much time at all for this to occur.
Have you seen shocked quartz? I mean, your thin sections, I didn't see anything that looked like that.
There's some funky looking things that I called metamorphic rock fragments. I mean, they didn't look like the classic shock quartz to me, but I'm not an expert on that by any stretch. But there's some weird grains in there. If it's not shock quartz, the provenance here, it's eroding some shear zones or something like that, where we're getting really strained, not shocked, but strained grains in there.
I've seen strained quartz in the metamorphic rocks.
Right.
So if you see it in the metamorphic rocks, you're going to see it in these Devonian rocks.
Okay, we have another one from online. Are there any other likely means for generating shock quartz other than bolide?
I remember I think there's some studies that from some structural deformation, you can get things that look like shock quartz. I can't remember the reference, but they were basically talking about how, people are calling these things shock quartz that really are not. And I trust Joe. Joe knows what he's doing. I mean, he did the universal stage. He just wasn't looking at thin sections. And so I think there's shock quartz there. Again, is it related to an actual impact ejecta blanket, or are we just eroding some older feature and it happens to be incorporated in the next step?
Regarding age relationships, if you look at the Huntley Mountain further west, you do have that thin marine zone in there, the Cedar Run conglomerate, and that is considered latest or uppermost Devonian. And that is stratigraphically lower than the Haystacks. So we've kind of traditionally thought that the Haystacks is probably Mississippian.
Okay.
However, back around 2006, 2007, on the southern bank of the Loyalsock Creek at the Haystacks Rapid, about 3 meters above it, there is a thin little paleosol there that has a little carbonaceous zone at the top of that. And then right above that is one of the Huntley Mountain fairly clean sandstones. So I sampled that and sent it off to Cortland Abel at the Kentucky Geological Survey. And Cortland was a great guy, but sometimes a little slow getting back to you. So years later, I contacted him and he said to me, yeah, I did finally have a chance to look at that sample, and I did find some pleomorphs in it, and they were lower Mississippian. So at least within 3 meters or so above that. Now, I haven't gotten the actual results from him, and that's on my to-do list to contact him, because there's a number of other things that he owes me as well. But with regard to this, it looks like it probably is lower Mississippian based on the plumomorphs that he identified in it.
You reminded me of something I've been thinking of too, is I started thinking, well, I remember in Utah, I was mapping in the Cretaceous in the Castlegate, I was in a fluvial succession, and then I had this bed, and it was partially silicified, and that was transgressive surface of erosion. A very different character than the Haystacks, but in that transgressive surface, I had dinosaur pieces and turtle bone and all kinds of stuff like this. So I was kind of thinking, okay, could this be, like you said, related to that cedar run conglomerate? Rosanna, they found that shrimp in the Huntley Mountain, which looks like a shrimp. And when I first heard about it, I was like, it looks like a shrimp. So I'm thinking, and part of in Utah is I looked at a lot of tidal indicators. And coming here into the Paleozoic, my eye was tuned to those looking in Utah, and I'm not seeing anything that looks tidal in this stuff. I'm not willing to completely dismiss it, but yeah, I think it's possible.
Okay, another question from online. With just a quick glance at the photomicrographs, the haystack interval seems to be more texturally mature compared to the Huntley Mountain. Do other thin sections show differences in sorting around it?
Yes. And grain size. And I will say that doesn't bother me. And I'm biased by my interpretation, because to me, if it's a Silcrete, it's developing along the water table. And remember, these channels are cutting into one another. So when I look, I've done actual thin section grain size measurements on these. I tell my students about it and they just glaze over as it's all doing that kind of thing. But you see, sometimes the Haystacks is a fine sand, sometimes it's a medium sand, sometimes part of the Huntley Mountains a fine sand, sometimes it's a medium sand. So, I do see differences, but I had maybe incorrectly attributed those to we're just in different channel systems. And these channels, again, are cutting into one another. So what we're seeing at Haystack Rapids isn't necessarily the exact same sandstone that we're seeing at Dutchman Falls.
And maybe you said this, and I just don't quite remember. Is there any sedimentary structures within the Haystacks?
There have been, I have not seen them, but some root traces, which again, when I think about that, I'm like, okay, could this be more of a pedogenic? Could this be a soil? And then if we're talking about a soil, well, that's a stable paleosurface, and that could be traced long distances. And one of the other things about it is, even though the sedimentary structures are gone out of it, you may have noticed in some of the pictures of the Haystacks and some of the outcrops, you would see these things that look like surfaces. I think those are just different channels, and you've preserved the base of the channel where it down cut into the lower one, but just the internal sedimentary structures are being taken out.
Just another comment. So after the field conference in 2006, Bill Bergonia got really psyched about drilling a core hole up in that area. And so he tasked me in 2007 to locate a site and drill a hole, which we did. And as we started drilling it, because we were starting a little bit higher stratigraphically than we thought, we were going to run out of money to be able to drill completely through the Huntley Mountain. And talking to him on the phone, Bill gave me the authorization to spend the additional money to be able to drill down to the Catskills. So that was our first complete section of the Huntley Mountain Formation that had been drilled. We did find the Haystacks in there. It's about 1 meter thick. And I thought that I could see, but really tough just looking at it in hand specimen, that there might have been some really incipient cross bedding, but more than that, it was that I did see a couple root traces towards the base. And so my initial thought was, oh, we got a paleosol here of some ilk, but that's one location.
And I'm glad you brought that up, because I was going to put that in this, and I think it was you that had given me the depth, and I wasn't sure if it was correct or not, so I didn't include it. But when I looked at that interval in the gamma ray log, it looks to be, it's part of a finding upward package. It looks to be part of a typical channel succession. And interestingly, if you remember that hole that was drilled east of there, that was the where we got the cuttings from.
Oh, yeah, right.
You know, when I put those gamma ray logs together, I can't correlate individual beds,
Right.
but I can correlate zones. And you can see that same approximate zone in that other hole, which is on the east side of the quadrangle.
Yeah, we drilled a hole years ago. It was a deep hole to be able to also look at the hydrogeology, groundwater hydrology. So it was a 6-inch hole, so we collected cuttings. And boy, oh boy, we looked and looked and looked. Now, it's hard to sample. We were trying to sample with a resolution of maybe every 3 feet. We were really pushing it. Aaron Beerley was involved with that as well, and Victoria also. And we never could see in those cuttings what we could say was actually Huntley Mountain. Now, maybe it's because it wasn't there.
Right, but that zone, I feel like, you know, again, you can't correlate bed to bed, but there are zones that I'm pretty confident between those locations are, you know, stratigraphically equivalent in some way. So there are periods of time, even though I talk about the Huntley as being this dynamic system, I think there are packages in there. And what that represents is that represent sequence boundaries. When I was a young graduate student, that's what I would have said, oh, they're sequence boundaries. But, you know, it's not always sequence boundaries. You know, could it be some sort of climatic indicator? And, you know, having looked at this stuff also, you know, the drill hole in Trout Run, you know, the Huntley Mountain there is an entirely different beast. It's very difficult to correlate between wells in the Huntley Mountain. At least in LaPorte, it seems to be a little more straightforward.
Got another question for you. Might there have been excess silica in the groundwater from the glaciogenic deposits, such as those from the Rockwell Formation?
That was one of my other thoughts about this. I was reading a paper, Cecil, and I cannot remember he's affiliated with, but one of his suggestions was that during times of glaciation, and you have all these lust deposits that are being formed, well, in some models, these things are blown out into the ocean, and those become chert deposits. That there's almost this correlation, like the Fort Payne chert, for instance. If you've ever looked at that, I've looked at it, and it's chert. You know, and so that's one thing I was thinking of too. Are we seeing, you know, if we want to try to invoke some sort of climatic signature to it, could it be very arid and you have all this wind-blown silt, this fine grain quartz that's blown in there and could be contributing to it in some way?
Is that who you were looking for?
Yes. Okay. Yep, that's right there. Yeah.
Yeah,
Glacial flower. Yeah,
Yeah,
glacial flower. Consider asking Dwayne Cecil, Dave Brzezinski, and Vic Schema. Okay. And that was another thing about it, and I didn't get a chance to do it. You can look at the grains, the individual quartz grains, and if they are very pitted, that could be an indication of being in one of these situations where the wind is basically abrading these things.
Our time is up, so we're going to thank Brett again. Thank you so much. Thank you for making the trip from Bloomsburg. I really appreciate it. It was really great to see you today. You're welcome. So as a reminder, sign in. Of those of you who are here looking for PDH credits, which I plan to get out this weekend. I'm not going on GSA or anything like that, so I should be able to get the certificates out this weekend. Sign in. And nominations for officers. I do want to not clarify, but add to, we're looking to expand in terms of, we'd like to do more, not just our traditional officers, but we're looking, if someone wants to chair the social committee, so we can resurrect our pre-meeting dinner, like we can explore that idea. We do want to get field trips back, but me and Mike can't do it all. So we're looking for help. So anyone who wants to help out, let me know, send me or Amy an email, and we'll get you on for the summer officers meeting, which usually includes some adult beverages. So if that's any enticement. All right. Well, with that, the meeting is adjourned. See you all in 3 weeks, May 9th.